Hello, in this video we will be exploring some of the larger and less known multi-passenger electric aircraft. Now some of them are being designed to run purely on battery power, while others will use a combination of hydrogen fuel cells and batteries, and the third type uses biofuel gensets. It is true that electric aviation has opened up new avenues for transportation. The term urban air mobility frequently comes up, which refers to transporting passengers by air from city center to anywhere in a 50-mile radius. This potential market is being targeted by many eVTOL aviation companies, for example, Lilium, Joby Aviation, and Vertical Aerospace. Although this market is profitable, but the real pot of gold lies in regional transport. It would be ideal to have an electric aircraft that can perform the role of a Boeing 737 or an Airbus A320, that is carrying 100 plus passengers to distances of 500 to 684 nautical miles. This roughly equates to a range of about 900 to 1300 kilometers. While the current battery energy density does not permit this kind of range, the hydrogen fuel cell system does. And with this market in mind, even if electric aircraft manufacturers are able to develop something that can manage a quarter of these requirements, then they are in good business. Studies have revealed that small scale, that is up to 5 passengers and a 100-mile range electric aircraft, are at least 4 times cheaper to operate compared to a conventional aircraft. This advantage diminishes with larger electric aircraft as the percentage of the battery to the total weight of the aircraft increases, which is the case when the required payload and range increases. Likewise, the monetary advantage also dissipates with the use of fuel cells or biofuel. Therefore, the goal of most of the aviation companies is to develop a pure electric aircraft that maximizes the payload and range while benefiting from cheaper power. These companies are not targeting the high takeoff and landing performance and therefore are not interested in vertical takeoff and landing capability. The larger electric aircraft will be emission-free, which ties in nicely with the net zero target for the aviation industry by 2050 that will be adopted by many countries. More importantly, they will be capable of providing cheaper transport and will be quieter with much lower maintenance requirement compared to conventional aircraft. Note that many governments are taking concrete steps for reducing aviation emissions. For example, Norway aims for all short-haul flights to be 100% electric by the year 2040, and Sweden wants all domestic travel to be fossil fuel-free by the year 2030. Bearing this in mind, the companies are targeting aircraft with capacity of up to 20 passengers and with 400 miles of range. The first such aircraft to make our list is the Eviation Alice. The aircraft was first showcased at the Paris Air Show in 2019 and went through a major design overhaul in December 2020. The wingtip propulsors were taken out and so was the boundary layer ingesting propeller at the tail. Instead, 2 pod-mounted propellers were added at the empennage. The V-tail made way for a conventional T-tail. The only thing that remained the same was the lifting body fuselage. The new design, although more conservative, has several benefits. The removal of tail propeller means that the long landing gear would not be required to avoid tail strike, which saves weight. The second advantage is that of having a clean, high aspect ratio wing. This is because the wing doesn't need to support the propulsor weight at the tip anymore, and so it can be made narrower and more efficient. The new Alice can carry 9 passengers plus a crew of 2. It has an expected range of 815 kilometers with a cruise speed of 407 kilometers per hour. Its endurance is 2.8 hours at maximum takeoff weight. The power comes from 2 640 kilowatt motors. Its wingspan is 18 meters. The second aircraft worth mentioning here is the ES-19 from Heart Aerospace, which has the ambition to deliver the first electric airliner certified for commercial flight by the year 2026. The ES-19 project has been backed by United Airlines. If completed to specs, the aircraft would just require 750-meter runway, thus utilizing airstrips in and around the city for operation. Because of electric propulsion, it is estimated that the operating cost will drop by 50% to 75%, and the maintenance costs are estimated to reduce by 90% compared to turboprops. According to details on the Hart Aerospace website, the electric motors used in this aircraft are about 20 times less expensive than similarly sized turboprop, and about 100 times less expensive than the cheapest turbofan. The first generation of the ES-19 will have a range of 400 kilometers with a 45-minute reserve. The range will increase as the battery energy density increases in the future. Many of the design details, such as the size of the aircraft, hasn't been made public. The third aircraft on the list is by the British company Faradair. They have come up with an interesting design which uses triple box wings and counter-rotating ducted pusher propellers. The BEHA M1H has a 17-meter wingspan and can take off and land using runways with length of less than 300 meters. The aircraft can carry 18 passengers and can be easily converted into a cargo transporter. It can fly at a speed of 370 km per hour with reduced noise. It can offer a range of more than 1800 kilometers or 1000 nautical miles. This aircraft's 500 kilowatt electric motor is not powered purely by battery but is hybrid electric, that is, it uses biofuel generator, which is the reason for its long range. A similar size aircraft in development is the ERA or the ERA. It is a 19-seater regional transport aircraft by the French company Aero. The ERA has a range of 215 nautical miles or about 398 kilometers purely on batteries. This aircraft again has stall capability and can take off and land within 600 meters. It has a very swift cruise speed of 300 knots or 555 kilometers per hour. It uses 6 small rotors for distributed propulsion that are mounted on its high aspect ratio wings for higher efficiency. The first flight of the ERA is expected in 2020 and it is scheduled to begin service in the year 2027. A more ambitious and innovative aircraft in this category is by Craft Aerospace. They haven't named the aircraft yet, but renders revealed a diamond box configuration with 16 propellers. The aircraft uses multi-element wings. It uses very large, nearly vertical flaps to achieve VTOL. It is a 9-passenger plane with a range of 1000 miles, that is 1600 kilometers, and a maximum speed of 345 miles per hour, that is about 555 kilometers per hour. Note that the box wing configuration allows for a smaller footprint of this relatively larger aircraft. Two other companies that have the experience of producing a functional electric aircraft and are now venturing into developing bigger electric plane are BEHA Aerospace and Ampere. BEHA Aerospace has already produced the E-Flyer 2, which currently has the longest endurance time of all electric aircraft that have been developed recently. It has a flight time of over 2 hours plus reserves. BEHA Aerospace now has its eyes on 8-seater E-Flyer 800. The aircraft was originally developed as a business jet but is being considered as a potential candidate for an air-taxi service by the German flight operator Air2E. Much of the design details are currently under the wraps, but it has been mentioned that the aircraft will cruise at speed of 320 knots or 368 miles per hour. It has been estimated that the E-Flyer 800 will have only 1/5 of the operating cost of traditional twin turboprop. Similarly, Ampere, which successfully produced and tested the electric EEL aircraft, has now come up with another concept that it is calling the tailwind. Ampere, that has till now been retrofitting electric propulsion to existing certified aircraft, will design the tailwind from scratch. It's a 9-passenger aircraft with a clean wing of almost 20 meter span. The propulsion comes from a boundary layer ingesting ducted tail rotor. This gives the aircraft its high efficiency. The details of this aircraft are also unavailable. It was noticed that the development of 5-passenger eVTOLs for urban air mobility was the target of many aviation companies a few years ago. From the list of aircraft presented herein, it can be seen that there is now a definite trend of development of fixed-wing electric aircraft with 6 to 19 passengers capacity. As mentioned before, this is to capitalize on the regional transport market, the size of which is estimated to be $10 billion US. Furthermore, as many governments are getting stringent on aviation emissions with specific targets to be met by the year 2050, grants and other incentives will be available for companies to explore this avenue. And with this, the video is concluded. Do tell in the comment section which aircraft has a design that you think will make it from the drawing board and will be seen in service in the near future. If you learned something from the video, then do consider giving it a thumbs up. Thank you for your attention.